This video is the very, very basic video about balancing chemical equations. If you're one of those people that really struggled, you missed the day when we learned balancing chemical equations, maybe you weren't really paying attention because you just were kind of burnt out or you didn't want to listen, and you're suddenly realizing that the test is almost here and the final's here, and you don't know how to balance, this video is for you. I'm going to walk through very slowly, showing you how to do a balancing equation. This is a very basic problem. Then you can watch my other videos that will help you to know how to do more complex problems. So I'm glad you're here watching this so that you can get caught up here, because balancing really is fun when you do figure it out. And a lot of people get really good at it once something clicks. So hopefully it clicks for you today. So I'm going to be given an unbalanced chemical equation. And I need to know a few things in chemistry to be able to understand why I need to balance chemical equations. So there's something called the law of conservation of matter. And this law tells us that you cannot destroy or just magically create matter. What this is really saying is that if I start with some reactants in a chemical reaction, I have to end with the same amount of matter as my products in a chemical reaction. Back a few units ago, we talked about like how when you exercise and you lose weight, that weight doesn't just magically just disappear. That matter doesn't disappear that you lost weight from. It leaves your body in the form of sweat, in the form of like going to the bathroom, in the form of carbon dioxide that you're breathing out, several different ways that can leave, but it doesn't just stop existing. So what we're trying to do here in a balanced chemical equation is make sure that we have the same amount of atoms of everybody on the left side of the reaction and the same amount of atoms of everybody on the right side of the reaction. Okay? So I'm going to start, my left side is the reactant side. I'm going to go ahead and underneath each molecule or atom I have, I'm going to go ahead and write who is involved in that compound, okay? So in this case, we have sodium right here all alone, chlorine right there, and then NaCl, I have Na and Cl right there. Okay. I have another video that tells you how to know how many atoms there are in a compound. Go watch that if you need further help with this one. But I think that this one's pretty self-explanatory, so hopefully you get this. Right here, there's only one Na, so I'm just going to write a 1 right there. Right here, there's 2 Cl's, because that little subscript says that there's 2, so I'm going to write a 2. Over here in NaCl, there's just 1 Na right there, and there's just 1 Cl right there. So, here's the trick with balancing. The only numbers we're ever allowed to touch are where I have these big blank lines. That is called a coefficient. And in math class, you learn that a coefficient is a big number that is multiplied by basically whoever it's touching. So if you had like 3x, that 3 is distributed to that x. Okay, same thing here. If I have a number right here next to this Na, it's distributed to that Na. All right, and for the NaCl, if I had a 3 right there, it would distribute to both the Na and the Cl. So, we are allowed to multiply by any numbers we needed to as long as they're whole numbers. And we can only do it in the coefficient slot. You are never, ever allowed to mess with these guys unless you're writing a chemical equation. But right here, we're just balancing. So I'm going to go ahead and I'm going to start with the following order. I'm going to look at my metals first, then my non-metals that are not H and O, then my hydrogens, then my oxygens. Okay? So I'm going to go ahead and start with my metal here. My metal is going to be sodium. It's on the left-hand side of the periodic table. I have 1 sodium on this left side, and I have 1 sodium on this right side. If something is balanced, it will have the same number of that element on both sides of the equation. So if I have 1 on the left and 1 on the right, then that means that my sodium is balanced. So now I can move on. Next down the list would be chlorine, because it's a non-metal, it's not H or O. I'm going to look right here. Chlorine has 2 on the left, chlorine has 1 on the right. Well, that's not balanced, right? Because 2 is not equal to 1. So I'm going to go ahead and I'm going to multiply by the smaller number. And I'm going to go ahead and put a big 2 right here. And the reason why I put a big 2 right there is because if I multiply my chlorine by 2, it's going to end up being 1 times 2, which is 2. Isn't that the number that I needed? However, when I multiply a compound by a big coefficient, it distributes to everybody inside of the compound, which means that now my sodium is also changed to 2. So my chlorines are happy because I have 2 on the left and 2 on the right. Now I need to ping pong back and make sure that my sodium is still happy. On the left-hand side, I have 1 sodium, but on the right-hand side, I have 2 sodiums. That is not balanced. So I'm going to go find the side that has less sodium, and I'm going to multiply by a number that makes it equal to the other side's number. So in this case, I would want to multiply this sodium by 2 so that that sodium became 2, so that then they would be even. Okay, so now my sodiums are both happy. They both have 2. My chlorines are happy because they both have 2. And this is a balanced equation. You might be asking, Miss M, why did you leave one of these blank? Technically, a blank means 1. But we are lazy. If you just leave something blank, we're automatically going to assume that it's 1. So technically the coefficients here are 2, 1, 2. Don't ever think that a blank coefficient is 0, because that's just not true. If you need further help with balancing, go check out my other videos. I'm going to have progressively harder and harder questions on those that will hopefully help you to figure this concept out. Good luck.